Hey everyone, in this video I'll show you how you can set up your Jetson Nano as a smart, connected mask detection camera called Mastcam. Mastcam can detect mask wearers and report detection statistics to a web server that can be viewed remotely. This video is a follow-on to my previous video which explains what Mastcam is and how it works. If you're interested in learning more of the hardware and software details behind Mastcam, go check out that video before diving into this one. This video gives step-by-step installation instructions showing how to install Mastcam on your own Jetson Nano. Now, fingers crossed, this mask detection technology will be totally irrelevant a year from now. However, this project still serves as a great example or reference design for other smart camera applications. One idea I have is to use this code to make a camera that can detect my cat and then set it up next to his food bowl dish and count the number of times he visits his food bowl each day before and after I switch him from a dry food diet to a deluxe all-tuna diet. Anyway, back to Mastcam. The instructions for this video will be broken into two parts, a basic Mastcam setup and a more advanced Mastcam setup. The instructions and all the code for Mastcam are available in our GitHub repository, which is linked here. It also has some tips for troubleshooting errors, so go check it out if you run into any problems during setup. For this tutorial, you'll just need a Jetson Nano, a USB webcam, and a laptop or desktop computer. For the basic setup, we'll configure Mastcam to run on the Jetson Nano and stream a live camera feed to our computer. For the more advanced configuration, we'll set up a local server on our computer to receive detection statistics from the Nano, store them in a database, and then serve up a web browser front end for viewing the data. If you work through this process, you'll get great experience with both Docker containers and web servers, which are both very valuable for software development and machine learning jobs. I'll show you how to set it up on a Windows PC, but this process will also work on a Mac or Linux PC. Alright, let's get to it. We'll start with the basic setup on the Nano. First, plug a keyboard, mouse, webcam, monitor, and Ethernet cable or Wi-Fi adapter into your Nano. You'll need to use a power supply rated for 3 amps or more because Mastcam takes a lot of power. This means you'll need to use the barrel jack power supply input and install a jumper for bypassing USB power. The link shown here gives more information on how to do so. I've also linked a good option for a 4 amp 5 volt power supply in the video description below. Once the desktop is loaded, open up a terminal. First, check the Jetpack version by issuing cat etc nv tegra release. This has only been tested with Jetpack version 4.4.1 and 5.0, so if you're using a different version, it might not work. Next, we'll pull the Docker container that has all the code for running Mastcam on the Nano. Pull the Docker container by issuing sudo docker pull mastcam/mastcam beta. Enter your password, and then the container will start downloading. This takes 10 minutes or more to download, so go take a break while it's working. Once it's downloaded, find your local Jetson Nano IP address by issuing ifconfig. Your IP address will be listed in either the ETH0 or WLAN0 portion of the output. Mine's shown here as 192.168.1.137. Open a text editor and copy-paste your IP address into it. We'll use it a few times during this setup process. Back in the terminal, we'll issue a rather lengthy command to start the Mastcam Docker container. Sudo docker run --runtime NVIDIA --privileged, which gives the container access to the host OS firmware, -it, which opens a serial terminal to the container, and then we'll set an environment variable Mastcam device address equals, and then we'll open our text editor, copy our IP, and paste it into the command. Then we'll attach some ports to this container using the -p argument, -p 1883, 1883, -p 8080, 8080, -p 8554, 8554. Finally, we'll tell it which container to run by adding Mastcam/mastcam beta. Enter your password, and Mastcam will start running and displaying messages in the terminal. If it encounters any errors, it will display an error message and automatically end after several seconds. Check out the troubleshooting section of our GitHub repository for tips on resolving any errors. Otherwise, after 30 seconds or so, it'll start to continually generate statuses message that say things like processed 300 frames, processed 600 frames, and so on. That means it's working. Mastcam grabs and processes frames from the webcam, but for optimized performance, it doesn't display detection results on the screen. We need to switch over to our other computer to view the live video stream. Leave the Jetson Nano up and running and move over to your other computer. Okay, so switching over to my laptop, I'll show how to set up the Mastcam video stream on Windows, but it'll also work on a Mac or Linux PC. To view the stream, you'll need to install VLC, which is a free and open source media player. If you don't have it installed, go to videoland.org, then download and install it for your operating system. Open VLC and go to Media, Open Network Stream. We can use VLC to open an RTSP stream from the Nano. Enter RTSP:// and then enter the IP address for your Nano, followed by :8554/Mastcam. Then click play. All right. If all goes well, you should be rewarded with a live video stream from your Nano. It'll show red boxes around faces that aren't wearing masks and green boxes around faces that are wearing masks. You can close the stream by closing the video player. Okay, let's go ahead and switch back to the Nano. First, pause and carefully feel the heatsink on the Jetson Nano, and you'll notice that it's getting pretty darn hot. That's because Mastcam uses lots of processing power and dissipates a lot of heat. Fortunately, the Nano will throttle itself or even shut itself down before it gets too hot. If you want to run Mastcam for more than 5 or 10 minutes, you'll need to get a heatsink with a fan like this one, which we used on our Mastcam prototype. Anyway, back on the Nano, I'll show how to stop the Mastcam program so the Nano can cool off a bit. On the Nano, you'll see that it also gives a warning in the corner if the processor is getting hot. You can stop Mastcam by clicking in the terminal and pressing Ctrl+C. The program will stop after a few seconds. Okay, that's it for the basic setup. At this point, you can set Mastcam up somewhere in your house and monitor mask usage. For example, you could set it up at the front door or entryway to check if your visitors are wearing masks. Alright, now let's get into the advanced setup for Mastcam. We're going to set up a local web server that allows Mastcam to store detection results in a database over time. The web server also lets you interact with Mastcam remotely, view detection statistics, and even download recorded videos from the Nano. The instructions get a little bit more difficult from here on, but stick with it and you'll have the server up and running in no time. For this part of the setup process, we'll continue working on the computer we use to stream live video from the Jetson Nano. We'll set up a suite of Docker containers that run a server with a database backend, web browser frontend, and MQTT message broker, which are all required for receiving, storing, and displaying detection statistics from Mastcam. Fortunately, Docker makes it pretty easy to get the server up and running. There are 4 main steps to setting up the server. First, we have to install Docker and Docker Compose, then set up the Mastcam server directory, and build and run the server, and finally point our Jetson Nano to the server. I'm going to show how to set the server up on a Windows PC, but the process is mostly the same for Mac and Linux. First, we need to install the Docker engine. Open a web browser and go to docs.docker.com/getdocker. Click the Docker Desktop for Windows link. If you're on Mac or Linux, go ahead and click those links and follow those installation instructions. On the Windows page, download Docker Desktop for Windows. This video uses Docker Desktop version 3.3.1. If you're using a different version, you may encounter errors. Once it's downloaded, open the executable and work through the install process. Restart your computer when the installation is finished. When the computer restarts, you'll be prompted by Docker to install WSL2, which is a Windows subsystem that allows for running Linux programs natively on Windows. Click the link to open the web page. Then, click on the WSL2 link to download the package. And then go ahead and open it and install it. Kind of have to move the window out of the way. Once it's installed, click the Restart button to restart Docker Desktop. Okay. Eventually, a Docker Desktop window will automatically open. Go into the Settings configuration and turn off the options to automatically start on login. Next, we need to download the Mastcam repository from GitHub. I'm going to use Windows PowerShell, which is kind of clunky, but it makes it easier to follow along. Find Windows PowerShell from the start bar and run it as administrator. These next couple commands are unique to PowerShell, so I'll also show the equivalent Mac and Linux commands to the right. First, move to the root of the C drive by issuing cd c. Then, download the Mastcam repository by issuing invoke-web request https github.com/bdtinc/archive/refs/heads/mastcam.zip /main.zip -output file c mastcam.zip. This will start downloading the Mastcam repository. For some reason, it takes like 5 minutes to download when using Windows PowerShell. Once it's downloaded, unzip it by issuing expand archive c mastcam.zip -destination path c mastcam. Move into the Mastcam server folder by issuing cd mastcam /mastcam main /server. We're going to build the Docker containers from this directory, but we need to set up some environment files first. Issue the following commands to make some copies of template files. cp database.inv.template to just database.inv, and then cp frontend.inv.template to frontend.inv, and finally cp backend.inv.template to backend.inv. Next, open the database.inv file by issuing notepad database.inv. Change the username and password to something of your choosing, and you don't really have to remember these because we're not going to be using them later. And then set the PostgreSDB to Mastcam. Then save and exit the file. Finally, begin building the Docker containers by issuing docker-compose up-d. This command builds the 4 different containers that make up the web server. It'll take a while to finish. It might pop up some messages asking to allow access to a server, which you can click yes on. Once it's finished, you'll have a full-fledged web server running on your computer. Now find your computer's IP address by issuing ipconfig. It's usually the one shown under the wireless LAN adapter or Ethernet adapter section. Open a web browser and type in your type your IP address into the URL, followed by :8501, and then press enter. This will load and display the web server front end for Mastcam. This is the interface we'll use to remotely view detection statistics from our Jetson Nano. If you see a connection error message, wait a few more minutes and then try refreshing the page. Now that we've got the server running on our host computer, let's switch back to the Jetson Nano. We'll run our Mastcam container again, but this time we'll point it at our local web server so it knows where to send detection statistics. Run the Mastcam container again by issuing sudo docker run -- runtime NVIDIA -- privileged -- rm -it, and then this time we're going to use some different environment variables. So we'll do --inv MQTT broker IP, and then here we'll use the IP address of the computer that we just set the server up on. In my case 192.168.1.145, and then another environment variable --inv MQTT device name. I'm going to call this my Jetson 1, and then --inv Mastcam device address. And for this one, we'll use the IP that we saved a while ago from our Jetson Nano, which we got when we were setting it up. Okay, and then we'll attach some ports, -P 1883, 1883, -P 8080, and -P 8554. Finally, tell it which container to run, saying Mastcam beta. Enter your password, and that should be it. If the device has access to the local web server's IP, then you'll see messages in the terminal about a successful connection and then occasional statistics about the number of people detected. Now you can open a web browser and enter the server IP address, which in my case was 192.168.1.145, and then :8501, and press enter, and you'll see the web server front end. This will work on your Jetson Nano, your server host PC, or any other PC on your local network. I'm going to use the web front end from my laptop. On the web page, click the Device Selection dropdown and select the My Jetson 1 device. This is the Jetson Nano that's currently running Mastcam. If you don't see the device on the list, try waiting a few seconds and then refreshing the page. The device status and some control options will appear in the browser. There's also a graph that shows statistics on the number of people counted over time. You can use the dropdown on the left to scale the graph by minutes, hours, seconds, and so on. For now, let's select minutes so it's easier to see the individual detections. The blue and green bars on the graph show the amount of masked faces detected, and the red bars show the number of unmasked faces detected. For this example, I sat in front of the camera for a minute with my mask on, and then took off my mask and sat for another minute. The bars show that there were 3 people detected during this minute, that they were all wearing their masks, and their masks were visible. Even though it was just me in the room, it shows 3 people because the counts increase each time an MQTT message is sent to the server. So once every 20 seconds or so, it'll increment the counts. It's something that we still need to fix in the code. When I take my mask off, it starts showing that unmasked faces are detected. The green line shows the overall percentage of masked faces that are detected. If you don't see any detections, go sit in front of the webcam for a minute, then come and refresh the page, and reselect your device, and it'll show you, we're going to set it back to minutes, it'll start showing you updated detection statistics. The browser interface updates in real time so it can give you up-to-the-minute statistics on faces. For example, you can see here that I was sitting in front of the camera, and then I took a break for a while, and then I came back and sat in front of the camera again. You can still open VLC Media Player and start a live stream from the Nano. There we go. All right. And then you can disable streaming by clicking the Stop Streaming button. Finally, the interface allows you to go and download videos from when masks were detected. Mastcam will save a video every time an alert condition is triggered. Right now, the alert condition is set to trigger even if there's just one person without a mask. This is changeable, but it requires modifying the code. To download a video, go ahead and just click one of the links and it'll start to download. Note that the Nano has to be powered on and running in order to download a video. Anyway, there we go. When you're done using Mastcam, you might want to deactivate the Docker containers running on your host computer. They take quite a bit of memory and processing power. You can stop them by going to PowerShell, or your command terminal if you're on a Mac or Linux PC, and issue docker compose down. This stops all of the running server containers. After you run it, the front end won't respond anymore. You can start them back up again just by going docker compose up-d. And you have to run these commands from inside the server folder in your Mastcam directory. All right, now that we know how the front end works, let's go test out Mastcam. Okay guys, so I'm here in downtown Bozeman, Montana, and I've got Mastcam set up to watch the sidewalk as people pass by and count how many masked and unmasked faces it detects. So I'm going to leave it set up for about 15 minutes and we'll see how it's performing. Right now I've got it connected over a mobile Wi-Fi hotspot and it is streaming live detection data to my laptop. So we'll just give it a few minutes here and then see how it's performing. Okay, so I've got about 15 minutes worth of footage now, and I'm going to clip out some interesting parts and talk about the performance. This first snip gives a good example of Mastcam's detection range. Mastcam doesn't start detecting a person's face until they're within about 15 feet of the camera. This partially is caused by the fact that my webcam isn't very focused at long distances. Once the faces are in range, they're accurately detected and classified. Now here's a good example of Mastcam accurately classifying a masked and an unmasked face. And then next you can see that as these people walk by, Mastcam actually doesn't work very well on the back of people's heads. The head should be detected as not visible, but we don't have many not visible faces in our training data set, so the accuracy could be improved by adding more labeled images of the back of people's heads. Here's a couple more examples of classifying unmasked faces. You also see that I get a lot of strange looks as people are walking past. And in this last example, you'll see that the first two faces are accurately classified as masked, but then this person that is wearing a mask is falsely classified as unmasked. Again, we can improve the accuracy of the detector by adding more training images to the dataset. Now let's go take a look at the browser front end to see what detection statistics have been reported. We'll select the downtown Bozeman device and group detections by the minute. As you can see, it shows the number of masked and unmasked faces detected over the last 20 minutes. It also calculates the overall percentage of mask wearers. If we were to leave this camera running for a full week, we could get some insight into valuable data like how many people there are wearing masks on the weekdays versus on the weekend. Now, look, I'm not wild about setting up cameras everywhere to track whether or not people are wearing masks. This is a sensitive topic, and I want to underscore that these cameras don't perform any facial recognition. They don't identify and track individuals. They're just counting the number of masked and unmasked faces that walk past the camera. One cool thing about doing all of this processing on the edge rather than sending it to the cloud is that there's less chance of a security breach or data breach where unwanted users can access the video. I do think there's a lot of cool applications for a smart web-connected camera like this one that can count and track objects of interest. Our GitHub repository shows how you can use your own detection model with our code to detect something other than masks. It also shows how to configure Mastcam and get it running on various hardware platforms. Go check it out if you're interested in learning more. To those of you who have made it this far through the video, thanks a bunch for watching. I hope you'll find some fun and helpful ways to use this Mastcam technology. Also, I'd love to hear if you're able to get everything set up and working correctly, so please leave a note in the comments if you do. As always, good luck with your projects, and I'll see you next time.